Okay, so we are finishing up lesson 2.4. Yesterday we ended with this example. Okay, and we briefly talked about the fact that they wanted us to find the average rate of change on this parabola where it decreased, which we said was from here to here, and where it increased, which we said was from here to here. Okay, you had to find, or you would have had to find that y value before you did this. What formula did we use to find average rate of change? Slope. Okay, slope formula. y2 minus y1 equals x2 minus x1. Okay. What form is this in? Intercept form, because it gave us our x-intercepts. And what form is this in? Vertex, because it gave us our vertex. Okay. Today we are going to be using standard form, which I wrote over here on the board for you guys. Okay. Y equals ax squared plus bx plus c. Okay, so we did vertex, we did intercept. Our only other option was standard, because those are the only three ways we know. Okay, so, what's that?
We're going to need to know that one for the test too.
Yep, this is still section 2, or section 4, excuse me. So, what I want you to do, first just listen here to the problem that I'm talking about, and then we will solve it. You're going to want to make sure to take good notes here, because just like the other two, I am only doing one example with it due to its length. Okay, so make sure you take good notes. Also, I had this discussion with the geometry classes. When you're sitting in class, whether it be Algebra 2 or biology or English, whatever, is it benefiting you, at all to sit there with blank stares and just be spacing off? No. Even if you're not going to be that person that's willing, to take a chance and throw your answer out there, even if you're not going to be that person, do you need to be thinking about it at least mentally in your head of maybe what step you should be taking next? Yeah. Don't be that person that just sits back and lets everybody else do the work. Okay? When we do calculator work, if you're just that person sitting back and letting somebody else punch the numbers, you're probably going to be the person that struggles more on the test. Okay? It's just the way it works. The other people have done it more than you have. Okay? It's just how it works. So, with that said, FYI, you will need a calculator today. So if you want to get one, go get one now. While you are finishing that, I'm going to go ahead and read this problem a little bit. This problem tells us a former NASA employee designs a model airplane that flies in a parabolic path. The table shows the heights h in feet of a plane t seconds after starting the flight path. Write and evaluate a function to approximate the height of the model airplane after 6.5 seconds. Well, to be able to approximate the height, you must know the equation of the parabola, right? Because then we could just plug in the time and we would get the height. So, they give us this chart. They give us time, which I'm going to call my x, and they give us height, which I'm going to call my y. And the only reason I'm calling them x and y is because that's what we're used to working with. Just so you know, in their problem, they use t and h. Okay? I'm telling you that because when you go in and type your answer in online, if you don't use t and h and you use x and y in your answer, it's wrong. They count it wrong. Okay? Because you're not using the right variable. So just be aware of that. We use x and y so much, though, if it were me, I'd change it to x and y and change it back in the end. Okay, because you're going to be doing so many things anyways. So they give us 5 hours worth of information. 19.1, 20.4, 19.9, 17.6, and 13.5. Okay. Now, they told us that this was a parabolic path, but what they didn't tell us is whether or not each one of these points is exactly on the parabola. Okay? So you remember when we did the best fit polynomial yesterday with the graph? Okay? This might be one of those problems. It's possible. Or it could be what I'm going to show you. Okay? So you got to be able to check it. Checking it is not that difficult. Okay? What I will want you to do, or what you will need to do, is just write out your y values. And you probably actually, I think we can do it this way. You don't need to write them out. If you have them in a list like this, oops. If you have them in a list like this, you should be able to just do it sideways like this. What we are going to do is we are going to start at the bottom, or the top, it doesn't really matter. Okay, let's start at the top so we don't get confused here and we always do the same. We need to take 20.4 minus 19.1. 1.3. And then take 19.9 minus 20.4. Negative 0.5. Hey, you got to make sure you do it in the right order, because if you don't, you will end up with the wrong answer. 17.6 minus 19.9. And 13.5 minus 17.6. Okay. If those numbers would have been all the same right there, then this graph would have been a line, because it would have been in the first degree. You do it once, first degree. Okay? We know from what we talked about yesterday, we're working in what degree? Second degree. So if I were to do this again, I should get all the same answers. Try it. Same thing we just did, but do it with the next one out.
First degree, second degree thing, what?
First degree means it's x to the first power. Second degree means I have an x to the second power.
Then what is this?
We're figuring out if I can write these numbers as an exact parabola, meaning are all these points on my parabola? Because if they're not, I'm going to have to do the line of best fit or the parabola of best fit like we did yesterday. I'm going to show you a different way to do it if they are all the same. Okay? What did you end up getting, Miranda? Negative 1.3? Thank you. Okay? So I do it the second time. Since it worked on the second try, that means that that is a second degree polynomial, which is a quadratic function, and that all 5 of those points are on my graph.
Will ever be more than just a second degree?
It could be, not what we're working with right now, but if you had to do it again and you got it on the third try, that would mean somewhere you have an x cubed. Okay, we're not going to worry about that right now. All I know is it took twice, so I have a second degree polynomial or a quadratic. So that means that this way that I'm about to show you works. If you do it twice and you don't get this, then you can't do it the way I'm showing you. Okay? You would have to use GeoGebra like I showed you yesterday. Okay? But since this works, this is the way you're going to need to be able to do it. And on a test, if this happens, I will require that you do it this way. I'm not going to let you just type it into GeoGebra. Okay, you need to be able to do this because technically we've already done all this work. You should know how to do it once I give you a couple pointers here. So, since it worked, I'm going to pick the easiest 3 points to work with. Most likely that's going to be 1, 2, and 3. Okay? So I know that I have the coordinate points 1, 19.1, 2, 20.4, and 3, 19.9. Can we all agree with that, even though you don't know where we're going with it? We have those 3 points. Okay. Now the next thing, hopefully you all agree with me on, is that this is an x value and this is a y value. X, y, x, y, correct? So I have 3 sets of x's and y's, right? I'm going to write 3 different equations by plugging in my x's and my y. Okay? Probably. Okay? So, I'm going to take the first one. My y value is 19.1 equals, now on this first part I have ax squared on this equation. So x squared is going to be 1, because 1 squared is 1, times a is just a. Plus, my x is still 1 times b is b, and then I just have plus c. Okay. And then I go to the next one. My y value is 20.4 equals, this time my x is 2, so when I square it I get 4 times a is 4a. B times x, which is 2, is 2b plus c. Now I go to my third one. My y value is 19.9. My x value is 3, so I get how many a's? 9 a's plus 3b plus c. Hopefully you see what we're going to do here. Okay, we are solving a systems of 3 variables. Okay. Now, the nice thing about this is when I look at that, my c's are going to be pretty easy to take care of, right? Yeah. Okay, I'm not going to have to multiply by anything, by any factors at all. Agreed? Yeah. Okay. We need to pick one and change all the signs, though, because I need one of those equations to have a negative c. The top one? Okay. It doesn't matter. The top one would honestly probably be easiest, because then on everything you're just subtracting 1. Right? Okay. It doesn't matter, though. So let's change that to a negative 19.1, a negative a, minus b, minus c. Is everybody good on why we just did that? Okay. So now I just have to take 2 equations, and I'm just going to start with my green one and my black one. So I'm going to have 20.4 equals 4a plus 2b plus c, and I'm going to have negative 19.1 equals negative a minus b minus c. And are we adding or subtracting? Adding. You're adding. You guys are probably saying subtraction because you're adding a negative, though, right? Okay, so technically you're subtracting, but if we didn't have negatives everywhere, it would be addition, right? Okay? Yeah? Yes. Do you need solution? I have contact solution in my backpack if you need some. Okay. 20.4 minus 19.1, or plus a negative 1.3, equals 4 plus a negative 1, 3a, 2 plus a negative 1, plus b, and those cancel, right? Okay? And so it begins. However, these are going to be, once you have it set up, these are easier than what we're used to working with. Okay, I promise you that. And it's because of that, you're always going to have this one equation where you plugged in 1 for x. Okay, that'll make it easy. So now let's take the blue one and the black one. So I have 19.9 equals 9a plus 3b plus c. And I have negative 19.1 equals negative a minus b minus c. Well, I'll say it with subtraction this time. We said plus a negative over here. 19.9 minus 19.1, 0.8. 9 minus 1, 8a. 3 minus 1. And the c's cancel again. Okay. The way you guys did it didn't turn out quite as nice as fourth period. When fourth period did it, they changed the middle one to all negatives, and when they got to here, they actually had a negative b and a positive b, and they just combined them together. We're going to have to do one step and multiply, looks like, right? Which isn't a big deal. Doesn't matter. Okay, so which one do I need to change? Red or blue? The red one by a factor of negative 2. So negative 2 times 1.3 is negative 2.6. Negative 2 times 3a is negative 6a minus 2b. Okay, and then this one's okay. So I have 0.8 equals 8a plus 2b. And I add again. Negative 2.6 plus 0.8. 1.8, right?
Yeah. 2a.
Equals, good, 2a. And the b's cancel.
Negative 1.8 divided by 2.
Good, divide by 2. Okay, so I'm going to make a list. I think I'm going to make mine down here. A equals negative 0.9. Okay. Do you guys think you can find B and C? Try to find B and C. Okay, I know some of you aren't quite there, but I do want to give you as much time as possible on your assignment. Okay, when you plug negative 0.9 into either one of these equations and solve for B, you should get what?
4.
You should get 4. When you take both A and B and plug it into one of your original equations, one of these three, you should get 16 for C, which Regan thinks is a big number.
Yeah, that's big. That's square.
Did you look at example 3? Look at their chart and then tell me how big 16 is.
Comparatively, it's a big number, but
Where you want me to scroll to?
when you're not,
Okay, stop.
when you're counting, it's not a big
Okay, will you come here real quick?
Yes.
Wait. I just want to figure this out.
Okay, we're going to finish this out. Okay. Now I have A, B, and C. Now, remember, we're trying to write an equation. Now I can write my equation. I know A, I know B, I know C. So my equation is y equals negative 0.9 x squared plus 4x plus 16. That is your equation.
That's our answer?
Yes. Okay. Now, the next part of the question says, after 6.5 seconds, how high is the airplane? And actually, before we do that, we probably better change this, right? This should be h, this should be t squared, and this should be t.
We got that wrong.
We'd have got that wrong if we weren't careful. Okay. So then, and I'm not going to solve this out with you, but if they wanted to know how high it was after 6.5 seconds, you would take 6.5 and do what? Plug it in for t, or x, yeah. In this case, t, yeah. Okay? So, that should give you the information to be able to solve every problem out of this lesson. Remember, this is the last lesson in the section, or in the chapter, so we got a test coming up. Okay? Yeah.